All right, so 8.2 is all about those arithmetic sequences, and here we are now. We are going to go ahead and we are going to analyze some geometric sequences. Metric and series. Okay, so once again, we're going to go ahead and we are going to start with a few definitions. And this geometric series now, or geometric sequence, is the ratio of any term to the previous term. This is, of course, consecutive. Is constant. And now we're working with ratio. So no longer difference, but ratio. And so now that we have ratio, we have this common ratio. And the common ratio is the constant ratio of terms. On this one, instead of using a D, we're going to go ahead, we're going to use that R to denote it. Now, with a geometric sequence, I'll switch back to this blue here, these look a little bit different. So geometric sequences are A sub n is equal to your first term, so A1, times that ratio to the power of n minus 1. And this might look a little familiar considering we just went over those chapter 6 tests. This looks rather exponential. Now, as a reminder, is that when we're dealing with functions are these kind of continuous, or they can be continuous relationships between each other, where a sequence, so we have our sequence here, only deals with that discrete amount. So these would be something that would look like that with these dots, but it still might have that shape that's similar to our exponential function. So why don't we go ahead and jump right in with an example. Example 1. And we are going to work with the series 27, 9, 3, 1, 1/3, etc. Okay, and so this is how we figure out if it's geometric, is that you take one term and divide it by the other. So 9 divided by 27, and you get 1/3. 3 divided by 9, also known as 3 over 9, you get 1/3. 1 over 3, 1/3. 1/3 over 1, 1/3. So this is, because that numbers were always 1/3, it was constant, is a geometric sequence. And we can say here that our ratio, or our common ratio, is equal to 1/3. Now definitely be careful here that you're working backwards with these guys, right? So for instance, on this one, we'll stick with this color, that you're taking 9 and then divided by 27 for that guy. So make sure that you're definitely working backwards on these to figure out your common ratio and not the other way around. So now when we write this, all right, we're going to go ahead, we're going to use this formula up here. This A sub n is equal to A1 times R to the power of n minus 1. It's super simple. All we need is this first term, which is 27, and our common ratio, which is 1/3. To go ahead and plug this in as A sub n is equal to 27 times 1/3 to the power of n minus 1. And that is how we go ahead and write these sequences and these rules for these geometric sequences. So let's go ahead and let's look at a few more here. Switch over to orange. And we have example 2. Let's look at this sequence. If you want to, feel free to pause it once I'm done writing the sequence and try it on your own. -16, etc. So -1, 2, -4, 8, -16, etc. Okay, so first things first is kind of test this out. So 2 divided by -1 is -2. -4 divided by 2 is -2. 8 divided by -4 is -2. And -16 divided by 8 is -2. If you were on Zoom last week with our class, we kind of talked about this rule here where if we had negatives and positives, we took -1 to the power of n. So we're going to kind of combine that rule with our geometric. And that's the idea that we're going to take our first term, and what's cool about this is that our ratio is -2. So instead of having to use this guy like we did last time, all you need to do is say a sub n is equal to your first term, which is -1, times -2 to the power of n minus 1, or if you went ahead and said that -2 n minus 1, just to get rid of that -1 out front and write the negative sign. And that's how you'd go ahead and write this sequence. I've got a few more examples for you because, as always, you guys know they present themselves in a few different ways. So I'm looking at a geometric sequence where a sub 6 is equal to 96 and a ratio of -2. So you guys have actually done this before, but we have to remind ourselves that a sub 6 is the point 696. All right, so now it's simply just using this information in our formula. So I'm going to use our -96, so -96, and I'm going to set that equal to a sub 1, because that's what I don't know. I don't know the first term. All right, times our ratio, and our ratio is -2 to the power of n, which in this case is 6, so 6 minus 1. And now all I need to do is I just need to solve for this a sub 1. So we have -96 is equal to a sub 1 times -2 to the power of 5 is, -32. Divide both sides by -32. And 96, let's see, so that's 3 is equal to a sub 1. Perfect. Now I can go ahead, I can use this piece of information with my ratio to write my sequence. So a sub n is equal to 3 times -2 to the power of n minus 1. Okay, one more example with writing these sequences. We are on example 4 for this guy. A sub 2 is equal to 12. It's a geometric sequence, and a sub 4 is equal to 3. This is all I know, that it's geometric, and I have these points. And these points are 2, 12, and 4, 3. Most of you guys already know how to do this. You aced it on your test, but we're going to go ahead, we're just going to review. And that is the fact that we're going to set up a system of equations. So a system. There we go. We're going to go ahead and we're going to set this up. So I know that 12 is equal to a sub 1 times a ratio that I'm not quite sure of, but I do know n, which is 2 minus 1. So as a reminder, this is n, this is n, this is a sub n. And again, this guy can be n, this guy can be a sub n when we're setting up these equations. So now I have 3 is equal to my starting value, a sub 1, times my ratio to the power of 4 minus 1. And now I simply just have a system of equations where I'm going to go ahead, I'm going to solve for this a sub 1 and replace it over there. Meaning that this is r to the power of 1. I can just go ahead and divide by r on this guy, which leaves me with 12 over r is equal to a sub 1. Okay, great. Now I'm going to replace it in my other equation. So 3 is equal to 12 over r, but I'm also going to rewrite this as r cubed. And now I can go ahead and this simplifies to 3 is equal to 12 times r squared, because this cancels out and this turns into a squared. Now I'm going to divide both sides by 12. 3 over 12 simplifies to 1/4. And when I take my square root, it ends up being 1/2 is equal to r. So I have one piece of the puzzle. I'll go ahead. Here's one piece of the puzzle. Now I need to go ahead and over here and replace it with my other one. So I can take 12 over 1/2 is equal to a sub 1. But 12 divided by 1/2, also known as 12 times 2, is 24. Now I have all my pieces of the puzzle. I can write a sub n is equal to 24 times 1/2 all over, to the power of n minus 1. And this is my formula that I'm going to use. So that's all of our writing formulas, but if you read our chapter, you also noticed that we had a little bit of the sums of geometric sequences. So sum of geometric sequences. And this guy, we use that s to go ahead and note that it's a sum. So s sub n is equal to, it's a little bit different. So your first term times 1 minus your ratio number to the power of amount of terms that you have, all over 1 minus your ratio amount. And again, I'm going to say that again, is that you're going to take your first term times 1 minus your ratio to the power of the amount of terms over 1 minus your ratio. So we're going to jump right into an example here, example 5, and we have a sum, so sigma, and we're going to our 8th term, and we have 5 to the power of k minus 1. So it's kind of a good idea to go ahead, and I'm going to write our other ratio over here. So a sub n is equal to a sub 1 times ratio to the power of n minus 1. So as a reminder, this number out front here is your first term. And this number inside the parentheses to the power is your ratio. So if I'm looking at the number outside here, there's an invisible 1 in my example, meaning that I can go ahead and say, okay, 1 times 1 minus my ratio, and my ratio is this guy, this 5. So 1 minus 5 to the power of, which is pink, however many terms that you're doing. So I'm going to go to the power of 8 over 1 minus 5. And now this is where a calculator really comes in handy, so you can go ahead, you can solve this with your calculator, and I hope that you trust me when I say 97,000 8,656. Hope that I did all my calculations there. Of course, feel free to check me. And then if you want, use your TI 83, 84 to check. So remember those, that video from last week about using your math button to check your sums. So I have, very last one is a you try. You know how this works. Pause it once you have the video, once you have the problem down. Sigma, we got I equals 1, so we're going from 1 to 12 of 6 times negative 2 to the power of I minus 1. So go ahead, hit that pause button. And I hope you're back because we are going to go ahead and solve this. So again, you're taking that first term, which is 6, times 1 minus my ratio, which is negative 2, to the power of 12 for this guy, all over 1 minus that negative 2. And again, a calculator is probably super helpful right now. But we have 6 times, this ends up being negative 1,365, which all equals to negative, I don't like that negative sign, negative 8,190. And that's it for 8.0.